Welcome back to the snake programming series. Last time we have created this snake game right here. And as you can see, we only render graphics. We haven't implemented any game logic yet. And pretty much this is just a rectangle being drawn depending on which arrow keys I press. And well, it's not really sophisticated yet. In the last part, we basically created a graphics library for Snake, and in this episode we're going to implement the actual game logic and make this a playable game. So let's fire up Vim and have a look at the code, and let's see where we need to pick up. One thing that is apparent is that we need to implement some data model for the snake, because right now the snake is only being drawn, or the cells that are filled for the snake are actually only being drawn on X and Y coordinates, and then, well, the snake is not, we don't keep track of the snake actually. We don't even, we haven't defined any data for the snake. So how long is the snake? Which coordinates does the snake occupy? Stuff like that. And I'm thinking about how to do that. And maybe it's time to create a data structure for the snake. And maybe it should be a linked list. Because a snake is a sequence of successive snake body elements, and we might have to model that. Technically it could also be an array which gets well, okay, it could be an array. Yeah, maybe that's even simpler. But I would like to learn something new, so maybe let's try to define the snake body. Maybe this is too complex now, but I really want to nail a couple of C concepts, not just for you, but also for myself. Let's not play around with arrays and stuff like that too much. We're dealing with C, so why not just use some pointers? And I'm defining a snake body here, or the snake body, or let's call this snake body or snake element. And let me just put a comment so that everybody is aware that this is like a linked list. So if you are aware of a linked list, for example, from Java or other programming languages, this is a type of list in which one element points to the next one. So let me just create a list for you. So this, well, not a list. Let's just create an array. So this right here is an array. Each box is one entry in memory. Okay, and one. So the first entry has index 1, the second has index 2, 3, 4, 5, etc. But the problem with an array is, if the snake moves, then the element at the head changes, then the element at the end changes, or it is appended, and arrays are not really suitable for that. So how about not using an array, which is a fixed data structure? How about we use a new data structure, well, that first occupies just one place in memory, which is the initial snake body. And if the snake gets longer, then it points using a pointer to the next element. And there can be other elements in between that we don't use. So this is just pointing to a different address in memory. And this one is also then pointing to another address in memory. They all have a next field, right, like this. And technically this next field is pointing to the next element, etc. So it goes on like this. And in case of an array, if, for example, we have to append something to the end, or if we have to delete the first element or update it, then we also have to get rid of this. Then we have to say this is now the new first element, and we have to shift all the indexes or indices. Now that is a problem in arrays, but in a linked list, we could just say we throw this head out. And this is our new head. And if we have to throw away the end, then we just say next right here. It's not this anymore, but we can say this is null. Just like that. So this is a bit of a different concept, and I would like to try this in this episode. I mean, this is really resembling, it's not really object-oriented programming, but it's really making use of data structures elegantly. So I really like that, and I think it's worth trying. So a snake element, well, contains a couple of fields. The first one is x and y. So that is the coordinate of the snake element. Then there needs to be a next element where it points to. And the next element is a pointer to the next snake element. So we have a snake element pointer next. Let's call it p next to emphasize that this is a pointer. And how do we know whether something is the first element? Because a snake always has a head, and then all the other elements follow behind that. Let me just write here or document here that this can be null in case of last element. Okay. So how do we determine the head? Do we even have to determine the head somehow? I don't think we need to determine it right now. Okay, let's just keep it like that. This is our snake element linked list thing. I'm not sure if the naming is ideal, but I think for now it's okay. Then I also don't think that we have to keep track of a length of the entire snake. I mean, that's the point of the linked list. You check if there's a next element, and if there's none, then we can... Yeah, if there's none, then we know it's the end. So I would like to now, what do we do next? We have now a data type that is able to track the snake. So in the event loop where we draw the snake, we should be able to, depending on how the snake moves, well, move the snake. Ah, right, we have to start with an initial snake. So let's delete all these snake coordinates right here. So all the snake handling can be removed. So right now this code is not valid anymore, but let's define the snake. So we have a struct snake element snake. And that is going to be x initialized at some x coordinate and some y coordinate. Let's just put it at 5, 5 for now. We can randomly initialize this later on, but this is not a priority right now. So at x 5, y 5, and the next element is null. So that is the next element we just discussed and which I tried to visualize here. So we are not pointing to a next snake element because the snake starts with a length of 1. Okay, so we start with a very small snake, which is just 1 cell big. Well, actually, this is completely a new concept for me, at least in C. So this is quite interesting to see whether that even works. So this is our snake. Then I would like, depending on which buttons we press, right here, I would like to move the snake. So if we press the right arrow buttons, we retrieve snake X and increment that. For the left arrow button, we decrement that. Then we do snake Y minus minus for snake up, and snake Y plus plus for snake down. So this way we update the snake. Seems a bit too easy right now, but I think it's... Yeah, let's see if it's even working. And then we need to draw the snake. Before that, we just used snake and then XY, and this would fill the snake's body at specific coordinates. But now we have a real data structure. We don't want to just draw cells depending on XY coordinates. We want to draw the real snake and visualize how it moves. So we need a new method to do that. And I would say let's create a new method that is called draw snake, and it takes as input the surface we draw to and the snake. Yep, that looks good. Oops. So let me just go here in in this line void draw snake. We retrieve or we receive an SDL surface pointer. Let's make it p surface. I know up here I didn't use p surface. I just want to stick to that convention now. Maybe let me just update it here. Surface. And here as well. Let's see here as well. Where else do I use surface? Here. And then also here, here, there, there. Okay, that's it. We refactor all the surfaces to start with p to indicate that this is a pointer variable, p surface. Then we receive the structure snake element, snake. And actually I would like this to be a pointer as well. P snake. Well, the point of passing a pointer, as far as I know, is that it's much faster. It's just pointing to some address in memory. And if you compare that with passing the actual snake, then the operating system or whatever, the machine would have to copy the entire information of the entire snake and pass it into that method over and over. So maybe it's faster to pass a pointer to what we want to draw, such that the data does not have to be copied. And then right here, how do we actually draw the surface now, or draw the snake? We can call our utility snake, and we draw the snake at this snake utility, we defined it up here, is just a utility to fill cells at a specific coordinate in a specific color. So this is not doing much. We maybe need to somehow now iterate over the snake elements. To do that, we need to first get the first element, and then we need to check the next element over and over again. So while pSnake next is not null, like that, maybe we can already use snake pSnake x pSnake y. Okay, what's wrong here? It must be p next. So if there's no next element, then we're going to draw. No, wait. While there is a next element. No. Damn it. We have to draw the first element always. pSnake x and pSnake y. So we always have to draw the head of the snake. That's clear. Then we have to check, is there a next element? So while pSnake next is not null, and here we do something. What do we do here? We draw the snake. Should we do this recursively? And then we pass a pointer to the snake element, which can be pSnake pNext. So this is the pointer to the next element. But this does not have to be a while loop then, if we recursively call this. So we have to okay, then let's do it differently. If pSnake is not null, so if the current pointer to the snake body is not null, then come on. So if the pointer provided is not null, then we draw the current pointer's coordinates, and then we call drawSnake on the next element. This would be a very nice recursive method to draw the snake. And I think it might work. And at some point, pSnake is going to be null, because the next element is going to be null. Actually, I find this quite nice. It's very neat, much better than an array. And then the snake is not being drawn anymore. So we are drawing the snake. It's perfect. I am the master of C. And here I have to pass a pointer to the snake. So let me just do address of snake like that. That's awesome. So far we are drawing a snake that is one element in length. Let me just compile this right here. Somehow when I pull up a new tmux shell, it forgets about the last commands I did. So I have to recreate the compilation command here, snake.c, remove that debug thing, and at the end I will execute snake. Okay, it worked. Let's see if I can move the snake. Yeah, I can still move it, and the snake's length is still increasing, or seems to be increasing, because actually we are drawing the elements, We are drawing new rectangles, but we are not deleting the old ones. And that is quite simple to do. Let me just... where am I? So we are drawing the new snake positions, but we have to erase the previous window. And that is quite simple. Before drawing the snake, we should just paint a black background. So we can do SDL fill rect, and then we provide a okay, let me just create a new rectangle here. That is going to be an SDL rectangle. That is going to be the erase rectangle. It's not really erasing something, it's actually overriding something, so let's call it override rectangle. And it's going to start at x0, y0, and it matches the size of the screen, width and height. And down here, let's go back to fill rectangle. We provide the surface, then the override rectangle, and we override the screen with black. So let's see, we haven't defined black yet, so let's define it up here as a new color black. Okay. And that is going to be color black, and surface is renamed to P surface. Okay, that's good. So let's execute that. And now, as you can see, the snake is moving. Of course, the snake has just one body because we haven't implemented the game logic yet, but this is already quite nice. Yeah. Okay, great. So this is working as expected. Now, maybe one thing we should do before we do anything else. Yeah. Right now, let's have a look at the game. The snake is updating. The snake's position is updating whenever I press the button. So I can make it move as fast as I want or as slowly as I want. And the real game is actually obeying a specific rhythm. So the snake moves, for example, every 500 milliseconds. And if I don't press a key, the snake is still going to move. And that is where the difficulty comes from. So to do that, I will create... Well, we somehow need to determine whether the snake is going, or we need to store whether the snake is going up or down, and then we will retain that value until it is being changed. How do we do that? We could introduce a simple flag up, down. But we also could make this a structure. Yeah, let's make a structure, struct direction. And the direction is int up, down, left, right. And then let me just document that only one value should be non-zero. Okay, so this is a structure that determines the direction of the snake. Maybe, does it make sense to store that within the snake? No, I don't think so. Then let's code that here. Structure direction. Direction is, and currently all the directions are 0. It would be actually very cool, maybe you know that, please write it in the comments, to know whether there's a data structure with, for example, 4 fields or something like that, and the data structure itself enforces that only one of those fields can be non-zero. That would be quite interesting to know. I can't think of anything right now, but maybe it's just yeah, maybe I know something, but I just can't remember it. So if you know something, write it in the comments. So we now have a direction type, and in the movement if clauses we will set, we can set direction equal to, and then we will say no, okay, here we can say direction dot right is true. Here we can say direction dot left is true. Then the same for up and down. So, but of course that doesn't work. That won't work properly because sooner or later we will have all the directions set to 1. So before we do anything, maybe at the beginning of the game loop, we have to reset the directions. So direction is equal to 0, 0, 0, 0, and that would be a reset direction structure. The problem with that is that we would create new values and overwrite them over and over, so that is a bit of an overhead. It might be simpler, or it might make more sense to reset the directions in place. Yeah, let's just do like that. Direction up is 0. Direction down is 0. Direction left is 0. Direction right is 0. Just like that. So no, this is not good, because still we will reset the directions, but if within the loop somebody clicks or types multiple keystrokes at once, they will all be processed in the poll events loop. So it is still possible to set multiple directions at once. So maybe we should really reset the directions here. Direction is equal to 0, 0, 0, 0. Yeah, okay. Let's just do it like that. I think this is the safest way. And I will need to cast this to struct direction, probably. Yeah, this works. And then only one of those values will be set to 1. And if there's another keystroke, then we will re-enter this if clause and the directions will be set to 0 again, and then again only one will be set to 1. Yeah, this should enforce that there's only one direction at all times. So now we have to move the snake according to the directions. And we can do that by... Oh, that is not simple, I think. So we have the snake, the snake's head. the movement direction is, for example, right. Just like that. So that means the snake is going to move to this box right here. But if the snake has a body, a trailing body right like this, then all the other elements also have to move accordingly. So we have to set this cell's coordinates to this cell's. Then we have to set this cell's coordinates to this cell's, etc. So that's going to be interesting. Then let's just try to do that. So, but first of all, let's move the snake. How do we move the snake? We move snake. We receive the snake itself. Maybe it makes sense to create a new variable pSnake. That is this right here, p. Where's the p? There it is. And that is equal to the address of snake, such that I don't have to retrieve the address over and over. That is pSnake. And then I can also use pSnake here. And we are moving the snake. That's straightforward. And we're moving it according to a direction. And maybe we can pass a pointer to the direction. Now, let's create a pointer to the direction. P direction is equal to address of direction. What? Ah, okay. Of course, I have to also put the asterisk in front of P direction. Okay, now we move the snake. Where do we move it? We need to create a new method up here, and I'll call it void move snake. We receive a structure snake element pointer pSnake, and then I'm receiving a structure direction pointer it's not pSnake, p direction. Okay, how do we move the snake? Let's first focus on the first element, just the head, because that's what we have implemented already. And that is going to be equal to I'm thinking if we had a proper direction data type, we could technically do something like this: pSnake x, and then we add the direction.x, just like that. But we have direction up, down, left, right. So maybe it's simpler to change the direction. Where did I define it? Right here, and we have to store dx and dy, the difference in x and y, and then we can store -1, +1, etc. in the direction structure. That would also be a bit more memory efficient, although I don't want to complain about the 2 bytes, or no, how many bytes are there? 2 integers saved, so that's 64 bytes or something like that, so not really that much memory. Okay, so if we move to the right, then the direction x is going to be 1. If we move to the left, then direction x is going to be -1. If we move up, then direction y will be -1, and if we move down, then direction y will be +1. So this is the direction structure. Of course, I have to replace dx and x and y with dx and dy. Okay, and now we have a nice data structure that is helpful for computation, that we don't have to introduce any if clauses here. And we can just call p direction dx, and depending on left or right, we will already know which way or how to compute that, whether to add or subtract something. Let's do the same for y, and let's see what happens if I execute this. Okay, this doesn't work, but I already know why. There's an error in line 80. Of course, the direction has to be set to 0, 0. Now it executes, but it's way too fast. So we can reduce the frame rate, the SDL delay, to, for example, 500 milliseconds, and that should leave us with a snaky game. Yeah, maybe that's even a bit too slow, but I think it's fine. Let's do 300. Yeah, and I'm not typing anything. The snake is moving on its own. So that is great. I'm just thinking, now, what should happen if the snake finds the apple? Then it should, well, at first, we first have to position the apple in a different spot as well. In a different spot, we have to position it in a new spot. And then we have to lengthen the snake. And actually the lengthening is the most interesting part to me, because, well, obviously that's dealing with our new data structure, the linked list. But let's first reposition the apple when the snake finds it. So we move the snake. Then if pSnake x equals apple x and pSnake y equals apple y, then what do? Then you recalculate the position for a new apple and reset apple. Then you reset the apple, and we're going to pass a pApple in here. We're also going to remove that apple method. And we're going to introduce a new drawApple method that receives pSurface and pApple, like that. And we're going to reset the apple up here, void reset apple. We're going to receive a new pointer type, apple, pepple the apple. Pepple. And that new structure, let's just introduce that before we do anything else. An apple is also defined only by x and y. Just like that. And then we set pApple.x equal to a random number between 0 and the screen width. So we position the apple anywhere on the screen, but not on the snake's body. Oh, that's interesting. Okay, how do we... Oh, okay. Okay, there are two ways to do that. We could either just create a random x and y coordinate for the apple and check if it's on the snake. If so, calculate a new x and y coordinate. Or we could retrieve all the x and y coordinates of the snake, somehow remove them from the list of possible results, and then draw or calculate an x and y for the apple. The former is the better option, definitely. So let's just create a random x value between 0 and screen width. So let's do width multiplied by rand divided by rand max. That is the maximum value that rand is ever going to return. And rand divided by rand max should... I would like this to be a double computation, not a double floating point computation. So let's just do this just to make sure that we receive, or that this part of the equation, or this end part of the equation, that this returns something between 0 and 1. And then we do the same for y as well. Let's do that height, double rand max. So we update the apple's coordinates, and then if okay, now we have to determine whether x and y are on the snake. To do that, we probably have to create a new method. Or we also have to provide the snake here, struct snake. Snake could actually also be a global variable, but let's just pass it here. So p snake let me just put a comment here just so that it's clear to anyone in the future. If apple coordinates collide with snake, try again. So how do we check that? We have to iterate over the snake and check. How do we do that? I mean, we are dealing now with a new data structure, a linked list, that is the p-snake. So let me just remind you that we iterate over the snake by checking the next snake elements. And now, how do we properly iterate over that? We could technically use recursion again. So if p-snake x is equal to... No, what the hell? I'm in the wrong method. Okay, if p-snake x is equal to p-apple x and p-snake y is equal to p-apple y. So if both coordinates collide, then reset the apple again. And this time we pass as the snake element pSnake, pNext, the next element in the chain. No, that doesn't work that way. Ah, no, sorry, that was bullshit. We have to, of course, check if all the coordinates collide. If all the coordinates of the snake collide. So that doesn't work that way. So if pSnake.x... No, that's completely wrong, sorry. We don't use recursion. We have to check for every element in the snake. Okay, what is the condition? pSnake next is not null. And then after the loop, what happens? Okay, this is really tricky. We have an int x snake x and int no. Maybe this should be a while loop. While pSnake next is not null. And then in that while loop we check all the coordinates. pSnake if pSnake x is equal to pApple x and pSnake y is equal to pApple y. So that means the coordinates collide. If that happens, then we break the while loop and we recalculate new coordinates. Else maybe we're still not really updating the snake elements we're checking. Wait, so we need to do the following. Snake element. We need to check a current specific element. Snake element. And the snake element we're checking is equal to pSnake pNext. Of course, the snake element must be a pointer. And how do we check the first element? So right here we're saying, okay, we have a snake element. And that snake element is the next element of the provided snake. But how do we check the first element? We have to say, we can probably say that snake element is equal to pSnake. Then in pSnake, no. Somehow something is not really tying together well here. So while pSnake pNext is not null. we have to check the first element and then we have to check if there's a next element. Actually, that is a while do loop. But I really think everything should be doable with a simple while loop. Do while. Okay, let me just look that up. Do while. Damn it. Do while in C. Do something while condition. Okay. Do something while condition. While p snake p next is not null. This way we now enter this check once, then we check if a next element is available. Yeah, and we also need to, well, after the check, okay, let's just store the current snake element, or the current element. Let's put it like that. P snake int pointer. This int pointer is, by the way, a data type that stores pointers. Or that is able to store pointers. Let me just pull up the documentation int pointer, because probably not everybody is going to be familiar with that. Maybe I'm even misusing it. It's coming from the standard C library, and it's a signed integer such that any valid value can be converted to this type and then converted back. Any valid void pointer. So this is usually quite useful for storing integers. Of course, for small projects, it doesn't really matter, but I'm just trying to improve my C, so I'm going to stick to the types that best suit what I'm doing. So as you can see right here, int pointer t, integer type capable of holding a pointer. So this is p current. If the coordinates collide, we break the loop. Else we set p current, the current element we're checking, to p current, p next. So we're checking the next element. Great, of course, yeah. P snake is holding the. Maybe we have to do. I wanted to be clever and use a new data type and experiment with that, but of course, I have to store the snake that I'm currently checking, and maybe it's better to do the following: struct snake element pointer p current is equal to p snake. So we start with the snake, with the first element of the snake. Then if the coordinates collide, p current. If the coordinates collide, then we break the loop. Else we update the current element to the next one. And then we of course have to check p current here as well. So we are doing this check. Then, once the check is passed, we are entering this while loop. I think we're still skipping over an element. So first snake element is being checked right here. If the variables don't collide, we assign the next element, and then we check in the while loop. Maybe we should check if pCurrent is not null. Maybe like that. I think this will work out. Okay, this resets the apple. But we only calculate new apple coordinates once. If we, however, collide, then we have to recalculate apple coordinates. So we can recursively reset the apple, and we pass the original input again, pApple, like this. And of course, let's put this right here in curly braces, curly brackets, curly braces. I can never remember how to call them. Curly brackets. What's the difference between a bracket and a brace? No idea. Brackets are always with the ones with the corners, but brace, well, no, I'm not sure. Okay, so if the coordinates collide, we try to reset the apple. And in that recursive call, we calculate new coordinates, and then we do the loop all over again until none of the elements collide. This will then have updated the x and y of the apple. And then down here, we can draw the apple. So okay, why is there an error here? Too few arguments to function reset apple. Because we have to also provide the pSnake, the snake pointer. Then we draw an apple. And we have no function to do that yet, but we can just call apple on pApple x and pApple y. Papple is undeclared. Why? Papple. I would have expected that I've already declared it up here, but apparently I haven't. So let's just do that. So we declare a structure apple, that is the apple, and it starts at what if I just don't initialize this? Then I create a pointer for it. Apple is the address of apple. And then I just call reset apple. Or maybe I don't even need to call reset apple, because it should be available here somewhere. Yeah, right here. But that is only being reset if the coordinates collide, so we have to reset it up here as well. So we reset apple. Why do I always put a B here? I have no idea. There must be somewhere that I'm typing often that's it's very similar. No idea. It might be public, which is used in Java very often, and I code a lot of Java. A lot. Apple, papple, apple, snake, papple, apple, papple, papple, snake. Okay, we reset the apple, but now that the apple is not initialized, let's check the method and see if it should work. Yes, we immediately assign x and y, and then we check if the snake collides, so that is good. Let's have a look at the implemented code, but there's an error somewhere. So let's see. Apple y is undeclared. Apple x is undeclared as well. Where do I use those? Ah, okay, down here. So we have to change that for Apple x, and just as a small reminder, Apple is pointer to apple. Apple y. Okay, there is no apple now. Why? Why is there no apple? Okay, I mean, I'm drawing the apple here. X and Y. Maybe it makes sense to print the X and Y values of the apple just to see that they are valid. So apple X is equal to this, and apple Y is equal to that, and we pass apple X, apple Y. Ah, there's the magic B again, and there it is again as well. So we are paint, of course. Oh my god, how could I not know, or how could I do that? I'm positioning the apple at random coordinates, but those are random pixel coordinates, not random grid coordinates. So of course they are way too big, and so the apple is not shown on the screen. So we need to check the width divided by, or no, maybe just columns, because right here we're dealing with the grids, with the grid. Let's see if that works. Now we have an apple. Let's see what happens if we eat the apple. Oh, yeah, it is being positioned at a new cell, which is great. I think this is already done now. Oh, perfect. I really like that. Awesome. Now all that's left is just to make sure that the snake gets longer when it eats the apple, which shouldn't be that hard, right? But actually, earlier we have discussed that, well, it might not be that straightforward. Depending on how the snake moves, we have to append a new, wait, okay. We have the snake's body. The snake eats an apple. And just like that. So then, in the next iteration, the snake is moving, for example, down. But a new cell has to be appended up here. How do we know that it has to be appended up there? Maybe it has to be appended opposite to the movement direction. Let's just see how we can do that. So this right here is the reset apple code. Going down, there's move snake. If the snake eats an apple, then we reset the apple. we lengthen snake. We lengthen the snake p snake, and we lengthen. How do we lengthen it? Ah, well, but okay, a new body should never be appended at the end of the snake. The snake is just keeping its existing body and is moving its head one forward, if you get what I mean. Let's just see. Lengthen the snake. Void lengthen snake. We pass structure snake element p snake. And then we have the existing p snake, that is what we pass into this method, and then we want to create a new snake element, struct snake element new. And that is, and what are the x and y coordinates of the new snake element? Maybe it should be a new head instead. Not a new tail element, but a new head element. New head. Let's just try appending a new head. So x and y of that new head are equal to p snake x, so to the current head, but plus the direction. We have to also pass the struct direction pointer, p direction, plus p direction. I don't know if this works, so this is just an experiment. Then p snake y is, oh no, the new snake head y is equal to p snake y plus dy, so the difference in direction, p direction dy, and then the snake's next element is equal to the old snake, p snake. So this is technically the new snake right here. And we have appended a head to the top of the snake. And now we have to somehow return that. Lengthen snake, and then we have to return. It's not really nice to append something to the head of the snake, because we would have to return that new snake somehow. We can't just modify this p snake structure in place, which I don't like. I would really like to modify this p snake structure in place. I think we can't just say, I'm not sure, maybe we have to try it. We can't just say p snake is new head. This might be locally modifying the variable. But let's see if that works. Great. And let me just remove that one printf statement we have introduced earlier about the apple coordinates, which we don't need anymore. Yeah, there's a warning. Lengthen snake is declared and there's an issue somewhere. lengthen snake structs pSnake and direction, and we have to, of course, pass p direction here. So let's see if the snake gets longer. No, it doesn't. And the reason it doesn't is because we are just modifying the snake pointer locally to this method, but it's not updating the actual pointer value passed. Yeah, we could change this by returning a new snake, which would be a new linked list. But I don't really like this. Maybe we should retain the head and still append to the tail. So how do we append to the tail? Oof. If the snake is... How do we append to the tail? Let's check that in Paint. So we have a snake. For example, this is our snake. Right here it eats an apple. So this is the apple. Then in the next iteration, that same snake looks exactly the same, except now the head or the apple became a new head. So that's why I wanted to modify the head in place. And we don't append any element here or here or here. We append the element here actually. So maybe it makes sense to return the new snake. We return the struct snake element pointer lengthen snake, like that. Lengthen snake, where do I call it? Right here. And pSnake is equal to lengthen snake, and let's see if that executes. No, segmentation fault. Lengthen snake, we pass the pointer, blah, 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 blah. Then this is the... Okay, where's the segmentation fault? Let's call GDB on the snake. No, first let's compile the snake with debug, with a debug flag so that we can debug it. And now let's do GDB snake. Then right here we can run it, and we should get a stack trace, or not a stack trace, but at least some information where that issue is. Snake C snake. Aha. There's a segmentation fault in this call in line 61. So let's exit and let's quit. Yes. Let's go back to line 61. This is this line right here. And the access to X and Y is wrong. Why is it wrong? We're updating pSnake here, and then where are we drawing that snake? We are drawing it here. After, no. The program crashes even before we enter this. So what's the issue? Draw snake, pSurface, pSnake. We move the snake. No, let's have a look at GDB again. Maybe we can learn something from there. Then what methods are there? breakpoints. Breakpoints. Help breakpoints. Set a breakpoint at a specified location. It would be cool to have to just have the program stop when we find the segmentation fault. Yeah, right here. I think it stopped. And now we have to somehow find out what variables are available. So let's just do help internals. No, stack. We want to know about the stack, so the variables that we currently have. Help stack. As you can see, I'm definitely not a pro at this. Print backtrace. Select stack frame. Well, doesn't really help. How do I see the variables? Examining data, help data. Help, what else is there? Help. Help stack. Actually, help stack sounds most promising. Backtrace. Okay, that is probably like the stack trace. What else is there? Stack status support trace points. By the way, I'm really doing this to learn GDB and the debugger myself a bit. And technically we could look at the code and probably we would find the issue quite quickly. It's just probably some stupid error that I introduced. But I'm taking this as an opportunity to find out how to use this debugger effectively. Because debugging C is quite powerful if you know how to do it. So let's just look something up here. GDB, view, variable, view registers, memory, view variable. Print variable name, info locals. Why was, when I type help, why is there no info locals documentation here? If I do info locals, no locals. Print all local variables excluding the arguments passed into the function. Info args, print variable name. Did I even properly compile the software to be debugged? This should be the debug flag. cc compile locals, compile debug. It should be -g. Produce debugging information in the operating system's native format. And then there's also produce debugging information for use by GDB. Let's try that. GDB. Let's run that in GDB and let's check what we can get here. Info locals, no locals, info whatever. I just guessed info stack, maybe help stack, or maybe better help info address, info args, registers, info registers. Yeah, great. Info frame, maybe. Info frame. Whatever, forget about it. This is really annoying. Of course. Oh my god. Well, one definite error here is that I need to include the curly brackets, my loved curly brackets, curly braces. Please write it in the comments. Right here. If this is working now, then sorry. What a waste of time. Quit, yes. Now let's compile. Of course it works now. Yeah, in 99% of the circumstances, just looking at the code is much more effective than firing up a debugger. Firing up a debugger is only good if you have one totally obscure bug that you can't find, but I'd also do this at work. All my colleagues, if they find an error, let's first debug something, let's run the system, but you can't find everything by looking at the code, almost everything. Maybe let's say 95%. Damn it, 95% of the problems can be found by just looking at the code. Maybe it's a bit different and see where you have pointers, especially if you do pointer arithmetics, memory allocation. These are very hard to find. But in other programming languages, Java, Python, whatever, some strongly typed languages. Python is not strongly typed, forget about that. But if you are familiar with the language you're dealing with, in 95% of the circumstances, you can find every problem just by looking at what your code is. Okay, great. What a great example. Segmentation fault. So we enter this case. So this is the case that's causing the segmentation fault. Aha, okay. Yeah, right. Because before we were missing these curly brackets. But now this call is only called if the apple and the snake collide. So it must be something in lengthen snake. Here we call the snake X. We lengthen the snake by creating a new head. We call p direction dx, p snake y direction dy, and then we're setting the next element to p snake. That is the new head. Of course, and then we need to instead of setting p snake, we need to return the new head. Because here we haven't returned the value, so p snake is going to be some obscure value, likely 0 or some trash value, a garbage value. And this can be solved by returning the proper element here. So let's have a look. I don't like that there's a warning in the compiler. You should always take warnings seriously. Function returns address of local variable. Why is that a warning? Is that not valid? Is there risk to returning the address of a local variable? I mean, I intentionally do that because that is our new snake element. Yeah, the problem is if you don't use that local variable anymore. Okay, I'm returning the address of a local variable, but that variable lives only in scope of that function. So this is a warning. It's valid C code, but it's going to break. So I have to pass, instead of returning a snake element, we will pass into it a new snake or a new memory space for the new snake element p snake new, and then the direction. And then we set psnake new. We set this, the value of that, equal to the new head. And here it's important to dereference, because if we dereference the pointer, then we're writing into the psnake new memory location. Let's see. Psnake, then we pass psnake new, which is, I think this can be psnake as well. Oh, is this a hack? If this works, then we can actually remove the new snake stuff and we can just overwrite the psnake. Let's see if that works. I suspect it will work. No, it doesn't work. Right here, we are creating a new head for our snake. Then we are assigning it to of course it doesn't work, because we are creating a new head, and then we are pointing that we're setting that new head. No, wait, what I'm seeing right here is a recursive snake definition. We set psnake as the next element, but then down here we assign psnake somehow to itself. So I don't think that is correct. So let's try to hack around this. I'm just creating a new snake element, temp, a pointer, ptemp, that is equal to, well, nothing. We don't need a value here. Then we pass ptemp here. This will then be the new snake value. And then psnake can be updated to ptemp. I think this will still not work, because this will likely still be a recursive definition. Let's see. Yeah. snake element ptemp. That is where we write the new snake into. Then we lengthen the snake. Snake element new head is this. And then pSnake new is set equal to the new head. I don't really see an issue, so let's see where that segmentation fault is occurring. Okay, it's in pSnake new equal to new head. Ah, of course. Well, this time GDB was actually already helpful, because here we have to provide the address of new head, obviously. No, we have to provide new head. No, then what is the issue? We dereference pSnake new and assign a new head. So what's wrong with that? It would be really awesome if C had better error messages. pSnake is equal to is dereferenced and set equal to new head. What is wrong here? pSnake x plus pDirection dx, pSnake y plus pDirection dy, and pSnake. Let's just printf. I want to see the value of... No, I can't just printf the new head. Maybe the issue is when dereferencing pSnake new, maybe it is not a valid address. But I'm actually creating a new address here. Let's just set it to some existing address. Struct snake element. I thought that if I just create this statement right here, ptemp, then it would automatically set an address. But yeah, I think this address is going to be null. It's null as long as I don't... Yeah, pointers are null unless they are initialized, of course. So that must be the issue. So let's create a new snake element temp that is equal to, it doesn't matter what. And then we update the pointer to point to the temp element. This will work for sure. Yeah, but what the hell is that? Oh, great. god. Of course, when eating the apple, we have to update the snake's body. So we lengthen the snake. Oh, and when the snake moves, of course, we need to propagate the entire body. So we move the snake. What happens in the move snake method? Yeah, we just update the coordinates of the head element, but we have to update the coordinates of all the elements. How do we do that? First, we have to update we have to set upgrade the body of the snake such that the second element of the snake takes in as position the coordinates of the first element. The third takes in as coordinates the position of the second element, etc. So if we move the snake in a direction, what happens? P snake xy, p direction dx dy. So now how do we move the second element to the first element's coordinates? Because we are dealing with a linked list, we have easy access to the first element. So we can update the first element first, but then we can't update the second element right after that because we have already updated the coordinates of the first element. So we might have to update the coordinates from the end of the snake, starting from the end of the snake. Or we just remove the last element and append a head, a new head. Let's see if that works. Remove last element. While p snake, oh well, struct snake element, and that's our iterator, p or let's call it p current, while and current starts with p snake, while p current p next not null, p current plus plus. So we set the current element to the last element, and then what do we do? No, we need to get the element before the last element. So p current is the last element, then we can do p current minus minus, or wait, p, oh, this is quite hacky. P current minus 1. Oh. How do we drop the last element? We have to check if p snake size of p snake is bigger than 1. Then we can retrieve the last element, that is pcurrent. Then access the one before the last element and then drop the pnext and set it to null. Okay, so we have removed the last element and now we have to update the first element by, how do we do it in the draw, in which method did we update the first element? In lengthen snake, we have created a new head. So let's just document that. Create new head. New head is this right here, psnake. Psnake is still pointing at the first element of the snake. Pdirection is still the direction. So that is all valid code. And then this is still the rest of the snake without the last element, which we just dropped. And then in here, in new head, we can, well, this is our new head. That's it. And then we can probably remove that code. And somehow we have to return that thing. So let's just use psnake to do that. Let's dereference psnake and set it to new head. Oh, if that works, then I am really surprised, because just a couple months ago I had zero idea of C, and now I'm dealing with these array operations and pointer operations and all of that. Let's see, there will probably be some segmentation fault. Yeah, of course, it doesn't work. Great. So let's fire up GDB snake, let's run it and see where the segmentation fault is. Doesn't even tell me where it is. Well, okay, if it doesn't even tell me where the segmentation fault is, maybe it's a bigger problem. From libstl. Error from libstl. What the hell? Why? Maybe something in draw snake. Let's put a printf here. Before draw snake and one after draw snake. Yeah, before draw snake is being hit, after draw snake is not being hit. So let's see what the error is. We have to probably print the value of psnake. So the value of, how do we properly print the address of a pointer? How do we properly print the address of a pointer? The address of a pointer can be printed using CU, I think. I think that was it. Let's just try that. And we're going to pass psnake. the U is long unsigned int, and pSnake is a struct snake element. Of course, that doesn't work. No, wait, why? Ah, no, it's a pointer. Okay, that's correct. But it looks like there is some address. Well, how does it look like if we just print an integer here? So if the error occurs here, then that means the issue is probably in lengthen snake or in move snake. I suspect it's move snake because that's the last thing we worked with. So let's have a look. Yes, we can. That is in move snake. And what do we do in move snake? Let's check. We remove the last element. Let's print test right here and see if we reach that part of the code. Yes, apparently we do. Yeah, and we still have the same kind of issue. We try to create a new head, and then we try to somehow write that head into. Of course, it's the same issue again. We have to pass the address of the new head. Come on. No, we are dealing with the dereferenced value. So why? The dereferenced value of pSnake is the new head. And then the new head is pointing to pSnake, which might be an error. Yeah, we have to move the snake and provide a new array or a new structure here in which we can return the new snake. So that is going to be a p new snake. How did I call it in the other method? pSnake new. Okay. pSnake. And then we can write that into pSnake new. Because the issue is pretty much, let me just visualize it again. This is our snake, like this. Then we are appending a new head to that snake, and we set pNext to point to the previous element. But we write this and this head right here, this new head, we write that into this object, so we have a pointer that points to itself. Okay, and now we have to provide in, for the call to move snake, we have to provide a temporary snake again. So maybe let's create the temporary snake outside of all of that business logic. And we're going to do the following. We're going to pass ptemp here. And then after the snake is moved, we can... No. Can we set pSnake back to ptemp? I'm not sure about that. think this is still the same error. Yeah. What if we don't do that? Oh, wait. No, that's not the same because we're now updating the address itself. Too many arguments for something. Before draw snake, p snake, printf. Ah, yeah, of course. Does it work? No, it doesn't. Before draw snake, after draw snake. Before draw snake, segmentation fault. Let's have a look at GDB and run it and see where the segmentation fault is occurring. We don't know. P-apple, y, p-surface, p-snake. We move the snake. And then there's somewhere an issue in draw snake. That means the pointer is wrong here, probably. Print pointer address in C. Let's have a look. Uint pointer. P. Printf p-snake. P-snake is equal to p. That should be the address of, or the address that p-snake contains. And let's try to print that. The address is still the same. Even after the first iteration, however, the snake should move. This happens only, this is good only if the snake moves. So if I, no. I think if the snake doesn't move in the first iteration, then move snake will break. Because then it will point to itself somehow. So we have to move the snake immediately. So the direction should never be 1, 0, 0. In case no event. So if direction is equal to 0, 0. I don't even know if we can compare structures like that. Can we do that? Probably not. If direction dx is equal to 0 and direction dy is equal to 0, then we just arbitrarily set the direction dx to 1 such that the snake moves. Still doesn't work. We reset the apple, we lengthen the snake. Maybe it makes sense to not just print the snake's head, but let's print the entire snake. So for struct snake element ptemp equal to psnake, then we, while ptemp has no next element, or has a next element, and then we increment ptemp. So this should loop over all the snake body elements. Then we printf ptemp. And ptemp is ptemp should be a pointer, of course. Let's see. And let's print the beginning of an iteration here as well. Starting to print ptemp. Let's see. Okay. We are starting to print ptemp. It has 3 elements. Why does it have 3 elements? E0, F0, 0, 0. And it looks like elements are appended quite quickly. Maybe let's also point the values of the ptemp pointer so that we know where they point to. So that is ptemp. We need to print the pnext. Pnext. Let's see. Right, something is wrong here. So ptemp has some value, pnext has the same value. So an element is pointing to itself. That doesn't work. So an element is pointing to itself. Let's check if it's only the head element. So this is the second element. It's pointing to a different address. Wait, shouldn't the first element then shouldn't the first element have a pNext field that points to the second element? So I would expect the address in pNext to be identical to this one. What the hell is that? So let's see where the first odd value is. There's ptemp, then there's pNext. Ptemp is then something doesn't really fit together. That's really odd. Let's have a look at how we set the head. We lengthen the snake here. Should we forget about lengthening the snake? Yeah, what if we don't lengthen the snake? Maybe we can exclude this potential source of error. Let's see what the result is if we print that. Yeah, there's still an issue. And the snake seems to be getting longer and longer and longer every time. So there is an issue with move snake for sure. Let's just comment out move snake and see what happens. There's still a segmentation fault. What? Let's comment out reset apple. There's still a segmentation fault. What about draw snake? There's no segmentation fault now, but what the hell? This is just a drawing method. It doesn't perform any logic, does it? It just checks if pSnake is not null, and then it draws the next element of pSnake, which should be okay. Then let's reset the apple. This is really hardcore stuff right here. I thought snake would be so simple, but yeah, I was making it hard for myself. Let's just do let's check the very first. Let's check the very first snake. So printf first pSnake is equal to pSnake, and it should point to pNext. It should point to pSnake, pNext. No, okay. So that is pSnake. Let's see where it's first used. it's first used in reset apple. Right here. But I don't think we changed the psnake inside this loop, do we? So we only loop over the elements of psnake. Yeah. I don't see an issue here. Psnake. We move the snake, psnake, and we return. Let me just remove those psnake are equal to ptemp assignments. I just want to see what happens if I do. It seems that the code is more stable then. So what is ptemp? Let's have a look. Here, ptemp is the address of temp. Temp does not contain any values. Let's just put 0, 0, null here, such that it is not initialized with garbage. That might be the error. Ptemp. It might have, yeah, maybe it was the case that ptemp contained, or the temporary snake structure contained garbage. So the pointer, the pnext, was also garbage. Then that was interpreted as a different snake, which also had garbage pointers. So maybe that was the issue. No, seems to still not look correct. Starting to print ptemp 7ffde0. Something is wrong. This cannot be correct. Let me just remove those ptemp assignments, and we're going to re-polish that. Did I recompile? Okay, so now we have the apple and the snake. Apple and snake. Apple and snake. This means that, okay, we're going to move the snake. So let's have a look at that method again. We move the snake psnake to a new, into a direction. And we write the result into psnake new. P-result. I'm just going to rename that to p-result. The result is the new head. Probably something is wrong with that approach, since it, we create a new head. Yeah, probably that all of this new head stuff is wrong. The new head lies in direction dx and dy and uses psnake as the next element. Technically, that's okay, I would say. and then p result is set equal to the new head. So let's try to printf psnake. Psnake should have an address. Psnake. And then let's print ptemp that has an address. Ptemp. And then ptemp pnext, because that should point to psnake. Ptemp pnext. Let's see. I'm going to remove or comment out those print statements. How do we do that? Probably have to do something like this. Yeah. Okay, so let's abort the application and have a look at the pointer values. Psnake. So psnake is, for example, this 560. Then ptemp is 570, and ptemp next is pointing to psnake, which is correct. But maybe it makes sense to also print psnake next. Psnake dot pnext. So maybe that's what the error, that's where the error is coming from. Psnake pnext is nil. And that is correct. That is correct, because there's no further element. So actually, I would expect that this is okay. This means that ptemp, pnext should also be nil. Which it is. Let me just enlarge it for you. Ptemp, pnext is nil. So that is correct. Psnake is 51090. Ptemp, pnext is 51090. So all of that is correct. When, okay, we move the snake, we create a new head, the new head is working. So what is not working? We move the snake. It is not moving, right? No, it's not. And the reason is that we are writing the result into ptemp right here. Then we can lengthen ptemp, and no, this will probably cause another bug. Let's just see what happens if we lengthen ptemp and then write the result into psnake. Yeah, this is probably the issue, because we have two pointer variables sitting close to each other, and they shouldn't have any circular references. This doesn't work. Oh, okay, we move the snake. The result is in ptemp. Now, should I adapt all this logic to consider ptemp instead of psnake? This sounds very cumbersome. What if I said psnake? The deref. What if I set the dereferenced psnake to the dereferenced ptemp? That doesn't work. I was thinking that psnake equals ptemp should work, but that is obviously the issue, but I can't really nail it down. Why it's not, or why it is the issue. Or rather, what to do about it. Psnake, ptemp, pdirection. Psnake, ptemp, pdirection. Let me just check using... No. Okay, we need another image. So we have psnake, which is this. This is now memory, okay? Memory, not the snake, not the graphical snake. This is psnake. Psnake. It points to the first element in memory. Then ptemp creates a new head, points to that, and this is then pointing to psnake as a next element. Now, if I set psnake equal to ptemp, well, then actually psnake should be this value right here, and then it should point to this, which should point to this, etc. I don't really see the issue. There is an issue, but I don't really understand it yet. What if we move the snake and we write the result into the original psnake? Yeah, it's a circular definition for sure. So we write a value into psnake that points to a next value, but that next value is the original psnake. Oh my god. But I also don't want to return a new value. We probably have to do the temp approach. So ptemp is now the real new psnake. Then I should be able to update psnake to ptemp. Why is there a segmentation fault? It might be because we have to do the same thing down here. Still segmentation fault. Psnake is equal to ptemp. Let's just have a look at the printout after that assignment. Oh, come on. Somehow my terminal is not working. Why? Great, it's not working. Then let's close that pane and create a new one. Not this one. Right here. And here let's compile the snake and execute it and see the result of that. So we have psnake that points to 70. Psnake next points to 60. Ptemp points to 70. Ptemp next points to 60. Ptemp pnext points to 0. Then psnake points to 70 and psnake pnext points to 70 as well. That is that's the issue. But why does it happen? That's the recursive pointer, or the circular pointer that I referred to. But where does it happen? I don't really know where it comes from. So let's just print f iteration d. And let's track the iteration count. Int I is 0 up here. And then I will increment that iteration count here. Okay, we have iteration 0. All of this is looking okay. And in iteration 1, the values are destroyed with a circular pointer. So that must be after all of this lengthened snake stuff. Of course, we have to use psnake equals to ptemp here. Let's see if there's still a circular pointer. So we have psnake, pnext, ptemp, pnext, pnext. All of that is okay. And in iteration 1, all of this is destroyed. Still destroyed. We don't even enter this code right here. Yeah. So it must be in draw snake, which is very weird. Let's comment that out. That somehow works. Are we up? Oh my god, guys. If I made a pointer array if I introduce a pointer modification in a drawing function, then yeah, sorry. So in the drawing function, we check if psnake is not null. Yeah, that is okay. Then we draw. And then we recursively call draw snake. So I don't get what the issue is here. What the hell? How can this be an error? Oh, we have to check. Also check before. No. I mean, we are calling pnext here. Pnext might be null, and we don't know it at this point, but we're checking it in the recursive child function then. So pnext is null. Is it ever not null? Do we somewhere in... Did we forget to initialize pnext somewhere? When we remove the last... Ah! That must be it. I think that is it. If when we remove the last element, we have to set the element before that. Actually, we did that. I mean, we had to point the last element to null. Do we need to do anything different here? We move the snake. Let me just print the result of all of that here. Size of snake is equal to this, and then let's do size of psnake. I just want to see the output of that. And the size of expects should be an unsigned int. Maybe you can use CU here. Size of snake is 8 bytes or what? Ah, it's probably bytes. Okay. I would like to know the number of elements in the snake, not the number of bytes. So we have to check size of How do we get the total size of elements in this pointer or in this structure? How many elements does it have? P current is the size. P current? No. int num elements. So let's create a number of elements, integer, or maybe even better, size t. Number of elements, we need to include standard lib for that data type, I think. Size. There we are. Number of elements is 0. If number of elements is bigger than 1, then we have to get the last element Let's just see if that works now. No. Is this way of retrieving the last element correct? P current -1, P next. Ah, that's the one before the last element. I didn't really save this, did I? So iteration 0. P snake next. Okay. P temp next, P temp next. P snake. Okay, and there's our circular definition. Why do we still have this? If number of elements is bigger than 1, set P next, set yeah, okay. Then create a new head. We create a new head here. Snake. The dereferenced P result contains now the value of the new head, which is okay, isn't it? What about lengthen snake? How about we print? No, that isn't even called. How about we print the values here? Did I save? I don't know. Let's just make sure. I think I saved. At least the last... Yeah, forget about it. Iteration 0, 90, 80, 90, 80, nil. That is okay. Then the issue is that probably the move snake in the second iteration uses the P snake, which is not... No. Is it being updated? Of course it is updated. This is by far the simplest project I have started, but because I wanted to try a new data type, I'm dying because of pointer errors. So mastering pointers is really important when doing C. P current, P next is not null. Okay. Then increment. No, we don't increment P current. We set P current to P current, P next. I mean, we can increment it in an array, but in our snake pointer, we can't just increment the addresses. Because they not necessarily sit in the same, sit in a successive string of memory segments. I don't get why it's still not working. So while P next is not null, P current is equal to P current P next. Okay, num elements is incremented, num elements blah 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 blah. P current is P snake, P current. So then the last element is being... this, of course, this also doesn't work. P current. Yeah, this also is an invalid access. This only works with arrays, because in arrays we know that they are ordered, but here we can point anywhere in memory. So this is not necessarily valid, because on the stack or wherever in memory we are, there can be elements in between those. So how do we get the last element, or the one before the last one? We could just do an inefficient loop here. Maybe if number of elements is bigger than 1, then while P current, let's rename P current here, P current, and replace it with P last. So while, and then let's do and then we have to check while P snake, we have to check struct snake element P temp, or no, let's do P before last. While P snake, no, while P before, okay, and before last is now equal to P snake, so we start at the top of the snake again. While P before last, P next is not equal to P last. We set P before last equal to P before last, P next. And then we eventually reach P last, which should be set to P, which should then be, no, the next element is going to be the last element then. So the P before last is then, after this loop, pointing to the second last. That means here we have to set the p next to null. If there's an error and you already see it, then sorry, let's try it. If the number of elements is 1 struct snake before last, the element before the last, let's start at the top, while the element before last, p next, is not p last, we update the p before last to the p next. And then eventually we set the p before last to null. Then we create a new head, and then we set that head on the result, which is completely fine normally. So there's still this circular definition. Number of elements is bigger than 1. Let's see if we ever reach that. Hello. We don't reach it. If number of elements is bigger than 1, we don't reach it. Why don't we reach it? Of course, because we don't eat an apple. So the number of elements always must be one. I think there might be an issue with move snake. For example, we don't consider that if there's just one element, we just need to update the coordinates of that one element. So if there's just one element, okay, let's cover this simple case here. If p snake p next is null, that means there's just one element, then return. Maybe we have to set the result as well. P result is equal to p snake, no, p result is equal to a new snake element, p snake. Actually, it's quite similar to that one down here. So let's copy that. So then all of that is p results. And the next element is null, because we only have a single element. What's the error here? Do we have to cast it to a snake element? For whatever reason we did have to. Segmentation fault, great. So if pSnake pNext is equal to null, then we set the p result. That's completely fine, I don't get it. In iteration 0, we have pSnake, then we have pNext, it's nil. Then we have ptemp, and pNext is nil. Yeah, that's completely fine. What's the issue? GDB snake. This is really playing with my brain. So let's run that. Segmentation false at printf line 182. We already have 182 lines, great. pSnake x pApple x pSnake y pApple x. So what's the issue with that? Ah, it's in the print statement. But why does it tell me that's line... Ah, it is line 182. Ah, okay, I'm calling... yeah, of course this statement can only be called if pNext has a next pointer. So ptemp, pNext, is not... No, if that is the case, only then can we print it. So... Oh, the code is working again. Let's see, it will crash now, for sure. Oh, of course. Great. What's the issue now? pSnake is that, pSnake next is that, ptemp. Let's just call GDB and run it from here so that we can see the error. Okay. This might be an error related to the snake drawing, because it's an error coming from SDL. But I don't get what the error here is supposed to be. If pSnake is not null, then we are drawing the snake. We are drawing the snake to the surface. And we are passing the next pointer. We're checking if it's null. If it's not null, let's just print something here. Printf. pSnake is equal to... Let's call this draw pSnake. is equal to this address, psnake. Then draw psnake x is equal to this value. Draw psnake y is equal to this. And draw psnake p next is equal to this. I don't see a problem with that. Let's compile and execute. Yeah. What the hell? Yeah, psnake is some address, and then suddenly when the apple is being hit, then pnext is pointing to the same address. What the hell? So if psnake collides with the apple, then we reset the apple and we lengthen the snake. Let's check. We reset the apple. We know that this worked from earlier executions. And then if the apple coordinates collide with the snake, try again. All of that should work and not modify the snake. Probably it's way more likely that lengthen the snake is the issue. So here we are passing psnake, ptemp. What the hell? Did I forget writing code here? No, that's the one where I created a new head. The new head is pointing to psnake right here. And then psnake new is pointing to the new head. Oh. I think that method is okay. Maybe there's an issue when we with the parameters we call it with. So we pass psnake and ptemp into it. Let's have a look at an execution one more time. So all of this looks okay. And here's the error. And it prints a lot of stuff very fast. How is that explainable? It prints the draw psnake very fast. Are there any other calls to draw snake? It prints that very fast because psnake is now a recursive or circular definition. That's interesting. So we lengthen the snake. Lengthen snake. we create a new head that points to pSnake. And then we set pSnake new to the new head. Maybe we just need to use a new temp variable here. Struct snake element. Maybe there's some interference. Length temp. Ptemp is equal to 0, 0, null. Access elements in Scala initializer. Ah, yeah, of course. Ah, maybe we can just point ptemp back to the address of temp. Not tempt. Temp. Because that right here is temp. It's still the original temporary snake element with that is initialized, and this is just a pointer to that data. Here we can make sure that ptemp is equal to address of temp. And we can make sure the same is happening here. Let's see. That is not the solution. ptemp is the address of temp. Maybe this approach is a bit bad. Let's just return a new snake element pointer in move snake. And then return p result here. And down here we return also, let's return p results. In reset apple we don't need anything. In lengthen snake we need to return a lengthened snake. Struct snake element pointer. Return pSnake new. And then here let's forget about all that temp stuff. Let's move the snake, the given snake. That will create a new struct snake element snake moved snake. Ah, it must be a pointer. Why do we even need to return a pointer? We don't need to return a pointer, I think. Let's just return the result directly without any intermediate variables. And then let's do the same in lengthen snake. Lengthen snake, there we return there we remove also the temporary stuff. Let's just return the new head. Then let's remove the temp stuff here. We can keep those print statements, but let's just print out the moved snake instead of ptemp. So the moved snake, yeah, okay. And then let's remove that down here. So the moved snake, if the moved snake, we move the snake, wait, we lengthen the snake right here, there we also remove the argument, and this returns also another snake. I would say if the snake was moved. No, the snake is being moved and then it is being checked whether it collides with an apple, and then it is lengthened. And the lengthened snake is written into snake or into moved snake. Then we draw the moved snake, p moved snake. This will definitely fail. Yeah, what the fuck? What is this? Draw p snake, x is 6 and y is 5. Draw snake, p moved snake. Lengthen the snake. That is written into moved snake as well. I'm not sure why I can only move in circles, but maybe that has something to do with a circular definition somewhere. Draw p snake, moved snake, moved snake. What the hell? Moved snake is this address. Of course, all of this has to be a pointer. So we create a new head and return that. Lengthen snake. This is now the moved snake. This is so stupid. Because we are changing memory in place and then things are weird. Oh. P moved snake, blah blah blah. No, let's keep that. Moved snake p next is not null. Move snake blah blah blah. If p snake x collides with the apple, draw snake. P moved snake. Lengthen snake. This is the new head. And we return the new head. We write that into moved snake. And this is probably the worst episode I've ever recorded. So we move this. Oh my god. Lengthened snake returns a lengthened snake. A lengthened snake. But writes it into moved snake. Maybe we have to create a new structure instead. Struct snake element lengthened snake. Why does it not move properly? The moved snake is this right here. Let's remove all those. I'm just going to remove everything if this doesn't work. We know that there's a circular definition somewhere. P snake. I don't care about P snake. I care about my moved snake. Let's forget about those pointers. Moved snake is this. Moved snake dot y. Then lengthened. If they collide, we pass the address of the moved snake here. Then we create a new lengthened snake. And here we pass the address of the moved snake as well. And then down here we draw the lengthened snake. Why is it not working? Did I not save? Segmentation fault. Passing argument 2 incompatible pointer type. Lengthened snake. Lengthened. What's wrong here? Ah, it must be the address of the lengthened snake. And that might be undeclared. We're drawing the snake here, the lengthened snake. If it didn't lengthen, we are just going to We're just going to draw the snake as such. And we're going to draw the moved snake, the address of the moved snake. This doesn't work, obviously, again. So let's just scan the code again. We don't need this counter. The direction of is positive x. P surface override. Okay, that's all fine. Moved snake is moved snake of P snake. I don't really like this P snake thing, but let's make sure that P snake is always up to date. After drawing it, we will set P snake to lengthened snake and here we will set P snake to the address of moved snake. Okay, this works. Huh. It almost works. And there's definitely some improvements now. Great. There seems to still be a circular definition when after the apple is drawn. And it must have something to do with this P snake thing. So we are moving the snake. P snake is a pointer to the old snake. The moved snake is the new snake. Then we are checking if the moved snake hits an apple. If so, we reset the apple and we lengthen the snake in one go. Maybe we should just do the following. We reset the apple. We set apple digested to true. That's going to be a new integer. Apple digested is false initially. And down here then if an apple was digested, then in the next iteration we will check that. So we will only move the snake or we will lengthen it, not both. If no apple was digested, then we will move the snake. Else we lengthen the snake, and then we will do the following. We will create a struct here, snake element updated snake, and the updated snake is going to be set to the moved or to the lengthened snake. I just want to exclude side effects between the move and the lengthen method. Lengthen snake receives as input the p snake. And then in any case we draw the snake. If the moved snake, yeah, maybe if the updated snake dot x, and let's do that same change here, and then we can pass the address of the updated snake here and here. And psnake is also going to point to the updated snake. Let's see if that executes. It doesn't because there's still an error here. Psnake. Let's remove that. This is costing me way too much time. It's Friday today. It's oh my. The sun is shining outside. I started recording this at 9. Now it's 12. I need to go out actually. Updated snake, reset apple, apple digested. If no apple was digested, then we move the snake, else we lengthen the snake. Why? Where is the circular reference? I don't get it. Maybe we shouldn't remove the last element, but update all the elements. What happens if we remove the last element? This is the pointer to the last element. Then we iterate until we find an element where pNext is null. Let me just print the snake length here. Snake length is equal to this, and let's do number of elements like that and execute that. Why does this not work? It needs to be that probably. Why does it not even print anything? Maybe this is an infinite loop. It's not even printing those printouts. Why? Remove the last element. If pSnake pNext is equal to null. Let me just check. C check pointer null. I don't even have an internet connection anymore. Great. So we have to do without. pSnake pNext is equal to null. Let me just update the apple coordinates because I spent too much time reaching the apple. Apple is not even initialized. But it will be initialized in reset apple. Okay. Then let's do a fixed initialization at whatever, 10, 5. This is the printf that I'm looking for. Somehow it's not even being called. Here it is being called. What? Why did the apple's position change again? And if I put the printf up here, the apple jumps. No, it doesn't. No. Okay. No, if I put it down here. No. Okay. Snake X, snake Y, and P snake. That's the new head. What happens if we just copy the snake? But that's not just the point of the linked list, honestly. Yeah, this right here is the problem. I'm updating the snake. This creates a new head. Then I'm setting psnake to the address of the new head. But the new head points to the old address. This is one of the stupidest problems I've ever worked with. This is the updated snake. Now all the code should work with that updated snake. psnake receives as an address the updated snake, which should also be the same as saying psnake the dereferenced psnake is equal to the updated snake, which of course doesn't work because the updated snake is pointing to the old psnake. Oh my god. So the result of this iteration is actually the updated snake, which is fine. No, but can we do this? Psnake is a pointer. We can point it to the new variable. The new variable has in memory that the pNext is the old psnake. Actually, I don't really see the issue. This is definitely an issue, 100%. And very likely I am referencing the structure up here, but since this is a local variable, after the loop iteration, it should become invalid memory because then the variable is destroyed, but psnake still points to that memory. What if we do the following? What if we make this static? Oh. What if we make this static? I know this is completely trash right here. Yeah, of course, it doesn't work. Static struct. Okay, what if we define it up here? This won't work either. Psnake is pointing to the address of updated snake. We don't even have to use psnake at all now. Maybe we can just use, well, this is horrible. Psnake, we move the snake, psnake. Let's move the snake, psnake. And we will move the snake in place. If there is no next element, then we can update the snake. snake, p snake is equal to the dereferenced p snake is now equal to this. Of course, that doesn't work. Move snake, move snake. That is okay, but down here we return something. So this doesn't work. We have to do p snake dereferenced is this new head. I think I'm completely misunderstanding some concept. Otherwise I can't really explain why none of this works. Expected expression before that. Struct snake element. Struct. Okay, we seem to at least reach we have a pointer to the snake element. Now, we have a pointer to the snake element. We move the snake. If the snake has no next element, we move it as such. If it has a next element, we remove it. I'm completely done and devastated. I have no idea what I'm even doing here, so this is really stupid. This was good old times where the code was still working. Let me just re-execute this. Yeah, this was working fine. And then I had this shitty idea to do everything using pointers. Yeah, so I'm really having a depressed face right now, especially because I'm wasting my entire day and I'm... Oh my god. So let me just replay all the changes to see where I might have gone wrong. all of this was completely fine. Let's see what that code looks like. Yeah, that's working fine, but there's no apple. Ah, right. And then the problem was the lengthen snake method. So right here we have the apple, we move the apple. Oh my god, I could have quit like 2 hours ago. So maybe that's the point where we should where we should try to re-implement the lengthen method. Oh, now I even accidentally deleted all the other changes. So what's the current state here? We have the snake, we have the snake pointer. We move the snake. We lengthen the snake if it's necessary. Guys, I'm giving up at this point. This is crazy. So sorry. Okay, I am now back. Let's see if I have an internet connection now. Yes. Okay. So what happened? I went for a run and thought about the problem a bit more. This is really hunting me. And now I also ate something, did some other stuff, and I'm back. I also looked some things up on Stack Overflow from my phone on how to properly do those pointer stuff in C, and all the sources point me to memory allocation, that I need to make sure that this properly works. So let's just look up malloc in C. CPP reference, yeah, that should be the same for C as well. Allocates size bytes of uninitialized storage. Good. And we receive a void pointer as a return. So can we make use of that? The snake is a p snake. It's a pointer to the snake. Now the snake is moved, and in move snake we set the x and y of the snake element. Now the problem is, as you know from the last couple of hours of implementing stuff, we can't just really change the snake here. To move the snake, we have to append a new head, and we have to remove the tail. And that doesn't work because, and this is something I have found out while thinking about the stuff from while running. Let me see if I can visualize it. So we have a pointer, p snake, like that points to this memory location. Then inside that method, we set the dereferenced value of psnake. Well, that is actually the contents of this block, of this memory block. We update this. Then we we update this. So this contains now the head block, the new head block, and the next element, the next, points back to snake. I think I already explained that. Yeah. So the solution would be to use a pointer, psnake, a pointer, psnake, and psnake, sounds weird, points to a pointer, psnake, and tells us where the head pointer is. It's difficult to explain somehow, but let me just try it. So we move the snake. Let's try it with a pointer, pp snake. How can we set x on that? We don't really set x on that. Okay, we have to make sure that if the snake has a size of 1, how do we know the size of the snake? We don't know the size of the snake here, I think. We don't really know the size of the snake. Because pp snake is pointing to a pointer to a snake. We can dereference pp snake. This will then result in a pointer, and then dereference this again. This will then resolve in the snake itself. We can count the snake's size. Let's do that in a new method. Int, or maybe let's return size t. Snake size, and we pass snake element pp snake. You can think of pp snake, the double pointer to snake, as the allocated memory to that snake. Or this is a pointer pointing to the pointer, pointing to the... Oh my god. Whatever. So if snake size, no. While, no, let's introduce a counter, size t, size that is equal to 0, while pp snake next p next is not null. Struct snake element current is pp snake, and then here we can replace that with current, and if it has a next element, then we say current is current dot p next. Incompatible types. Of course that does not work because this has to be a pointer, and then we can dereference that like this. And in this while loop, we do size plus plus, and then we return the size. By the way, I made myself some chocolate cappuccino. It's awesome. I love that. Even it's so much sugar. And I try to avoid that, but it never works out because this is really, really delicious. Okay, this is the snake size. Then we check here if snake size of the pp snake is bigger than 1. Or if it is equal to 1, then we update x and y. I have the feeling that this will result in some code in the very end, which I don't even understand myself. So this is going to be psnake dereferenced, pp snake dereferenced. Let's just compile and see what happens. Okay, and of course we also have to update that call in the moveSnake method right here. Here we work with psnake, so let's have a look at where that comes from. It's up here. And I would like to pass the address of the snake. So this right here is the snake. This is the address of the snake. And this is the address of psnake. conflicting types for, this is PP snake. Then what do we do? Where is that p snake used? Here we have to pass in pp snake when we move the snake. And let's see if we can get it to compile now. Yes. Okay. It compiles at least. It does not yet move the snake. I think a problem might be when we do we move the snake properly? If snake size is 1, let's just print f and print the snake size is equal to that snake size. Let's see. Snake size is incredibly large. Oh, of course. What did I do? I pass the pp snake to the snake size method up here. This returns I pass into it the pp snake. I dereference the pp snake. And then check if there's a null. Print no. Let's call the size list size. I just want to make sure that the name size does not collide with anything. List size. Okay. Now the snake size is what do I even provide here? This is the snake, this is the p snake, and this is the pp snake. I don't see an issue so far. Then we move the snake right here. Let's include assert. I also want to play around with that a bit. Assert that pp snake is not null. Wait, is that assert even executed? C assert. C assert is a function like macro. If and okay. For the assert to work, I must have debug mode enabled. Okay, the assert is at least entered. That is good. And when let's see if it's still entered if I if I remove the debug flag. Oh yes, it is still. Okay. Then probably it's excluded in case, or only in case, I explicitly remove that macro. So I'm asserting that ppsnake is not null. In case I assert that it is equal to null, then we should get a failure. Yes, the assertion failed. So this way we can catch bugs. And we have to assert that the dereferenced ppsnake is also not null. Okay. What else is there? Then in snake size, let's see, what can we do in snake size? We can again assert that snake and ppsnake psnake are not null. Maybe we should assert as well that this is not null. Okay, what's the error here? There is an error, invalid operands to binary have struct snake element and okay. ppsnake, then we must maybe check that pnext. No, we're checking pnext when counting the size. So pnext can be null. We're checking that here. So here we are dereferencing ppsnake, which is leaving us with psnake, the pointer to the snake. And this is then the current pointer. If current, oops. Maybe we have to start with a list size of 1. But to do that, we have to first check that the provided snake is, well, let's just try that without checking. Okay, the snake size is still completely wrong. Current. How do we know that current is a valid snake element? Is there any way to know that? How do we know that current is a valid snake element? Assert current x. No, we can't really do any asserts here. Well, okay, we can assert that. We could assert that current x is bigger than 0 and current x is bigger than or is smaller than columns, and current, this is not really having anything to do with the size, it's just checking that we're operating on valid data. Current y is bigger than 0 and current y is smaller than rows. Let's see. Okay, seems to be the case, otherwise the assertion would have failed. So what happens if I change the list size from size t? No, I'm probably printing that wrongly. Where do I print the snake size? I'm printing it here. How about I print it as a regular integer, as a signed integer? It's still wrong. How to print size T in C. Yeah, ZU, unsigned decimal. So that was correct. Oh my god, I know it. I'm not pointing the snake size here. I'm pointing I'm printing the function pointer because snake size is the name of the function, and I need to create a variable here that is size t, snake size, that is equal to, oh well, maybe not snakes. Oh well, let's call it snake size. It should mask the function. Yeah, you know what I'm saying. The function declaration. Does it? No, it overrides it, or it collides. So, snake size is equal to, yeah, why can't I just call this snake size? Let's call it size. I don't really like calling things size. This sounds really a lot like a blocked variable. What the is nice? Size. Size. Size is 1. Okay, at least that. That is now correct. So the size is now 1. And I should be able to move the snake around here. Yeah, all of that is still okay. So we are moving the snake. In moving the snake, we say size. We calculate the size. If the size is 1, then we do the following. Else. Maybe let's do the else case here. Else. We need to, what do we do? If the size is bigger than 1, let's try to do it differently this time. Append snake element at the end of the linked list. Okay. That means we have to traverse the entire linked list. Let's print this out. And also, when we move the snake, we have to check. Wait, where is move snake called? It's called here. Yeah. Okay, we move the snake. That means we don't have to append anything to the end of the list. We do that in lengthening the snake. To move the snake, we have to update the x and y coordinates of all the snake elements. So, how do we do that? While, or let's do the following. Snake element p snake p current is equal to the first element of p snake. I'm not so sure about that. What's the warning here even? Unused variable, okay. While p current p current p next is not null. I think we don't even have to do that not null check. Invalid type argument. I think we don't have to dereference p current. So we start at the top of the snake. We get the snake's x, current x, is equal to p current x. And then we do the same for y. That is current y. Then the head of the snake moves somewhere else. Now, how do we update the head of the snake? Like that up here. And I think we can store those values out here. Current x is equal to p current x, current y is equal to p current y. And then okay, those are the first values. And inside the while loop, I think we can then update x and y. So we update x and y, and then we say p current is equal to p current p next. And before updating those, we can update the local variables current x and p current x to save them. So we are saving the intermediate value. We're also saving it here. Maybe that saving outside of this loop is not necessary. Maybe we can do this. Then we are updating the value according to our direction. No. Doesn't work like that. The current x, p current x, should be then set to the previous x, and y should be set to previous y. Previous x no, wait, this is really confusing. The first element is updated by dx and dy. The second element is set to first x, first y, just like that. So this right here is the first element. And we save the values for the second element later. And then we update the first element's values pretty much according to those rules right here. Then we check, does it have a next element? Of course it does have a next element. Then we set the next elements. Then we update the current element that we're checking. We then also update the current elements values previous x. Yeah, maybe let's rename that to previous x and previous y. Yeah, why not? Let's see. Code still seems to work, but of course that is only because the snake is not growing. So let's start with a snake size 2. Struct snake element snake head is equal to 4, 5, and it's pointing no, let's do it a bit simpler. Snake tail. This right here is the snake head. Yeah, has an end of null. Let's do this 6. And the snake is then pointing to the snake tail. This should be a size 2 snake. And that is working. That's awesome. Okay, at least we have some intermediate result. That's good. Okay, that's awesome. Then I'm wondering, why is the snake not immediately drawn correctly? Right here it looks like a single cell snake. So let's see. In draw snake. We have to check, is the pointer null? Actually, that looks correct. So we are moving the snake right here. Let me just check if it also works with a snake this size, with an even bigger snake. Snake tail pnext is equal to address of snake tail2. Oh, this doesn't work. And that might be a hint for an error. Snake tail pnext is equal to address of snake tail2. The size is correctly determined to be 3, but it does not draw the snake correctly. Let's see. We're checking if the provided. Maybe we should also pass here a double pointer to the snake. Maybe this is a bit more powerful. And we have to check assert. First of all, pp snake is not null. Then we also assert that the dereference of pp snake is not null. And then we check wait, this is a double pointer. This is a double pointer. Basically a pointer to a pointer to the snake. Then if we do this, what do I expect here? Of course, here I have to call dereference pp snake x and dereference pp snake y. pp snake is a pointer that you mean to use, huh? Fill cell XY on, yeah, all of that is fine. Okay. Segmentation fault. Snake element pp snake. Then we have to go to the draw snake call and make sure that they pass, that pp snake is passed here. Segmentation fault. Where is the segmentation faulted? GDB snake run. In draw snake. Okay. I think I should pass again the GDB flags. Run. Aha, okay. So the issue is in this call and snake C, line 66. Right here, of course, we need 2. No, what's the error? If we dereference PP snake, this dereference operator and the pointer cancel each other out, and we are left with P snake. We have to check that P snake is not null. P snake. The pointer snake is not null. Should be a totally valid statement. Expected struct element, but argument is of types blah blah blah. Let's just recompile and see if that error persists. Yes. Line 58. 58. Draw snake. Expected struct snake element, but argument is of type struct snake element. Where is it coming from? I think I know it. Because it's a recursive call, we are calling this same method here again. And we're passing pSnake, pNext. And pNext, yeah, is obviously not valid, because this is a simple pointer. No, let's make this. Let's do this differently. So to draw the snake, we have to loop over the pSnake while pSnake is not null. Then we set, okay, pSnake is set to the head of the PP snake. Then we check then we draw that pSnake X, pSnake Y. Then we update pSnake to the next element. How do we do that? We can't just do plus plus. Ah, right, yeah, obviously. psnake pnext. Still, it's not properly drawing the snake. That means probably something is wrong. And I assume my definition here is not correct. So I have the snake tail and tail 2. Snake's pnext is the snake tail, and the snake tail pnext is the snake tail 2. Should be okay, shouldn't it? Then let's go back into the draw snake method and do the following. We assert that the provided double pointer is not null and the provided target is not null. But we also have to check here. What can we check here? We can't do this check because, well, null is a valid entry. Yeah, obviously. Then we can probably assert something about the snake size. We draw the snake, and we should also know the snake's size. Let's do assert snake size and the snake size is, well, let's just hard code this to 3. We have 3 elements right now. I don't get it. Oh. If I want to use the snake size method, I have to put that method below the other one. Okay, we assert that. No, this is wrong. Assert that snake size of pp snake is 3. This works, interestingly. But then we should also count here debug snake size is equal to 0. Debug snake size. So I'm just adding assertions in the code to be able to catch errors. And then we assert that the snake size is equal to the debug snake size, which is the case. Debug snake size is correct, while pointer to snake is not 0, is not null. We draw the x and y, and then the p next is set as the current pointer to snake. Draw snake, p surface, pp snake. Yeah, I don't get what the problem is here, honestly. Let's create a new method that is called void print snake. And it retrieves a struct snake element pp snake and we iterate over that snake. We can probably just copy that while okay, struct snake element p snake is equal to that, while p snake is not null, print snake. So we print all the elements. Let's do a counter. Counter is 0. Let's print f. Element number. Number 1 is this, or number 0. Then snake x is equal to this. Snake y is equal to this. And snake, what is there? P next is a pointer that is equal to P next. And we can also print snake self, that is the own address, that is equal to P snake. And after printing all of that, we update P snake to P snake P next. So we iterate over the next one. Then we can print the snake, for example, down here somewhere. Well, let's print it here. And see how that looks like in an executed fashion. So we have element number 0, snake x, snake y, snake self, and of course P next is null. Why is it null? I don't get it. I mean, here we set snakes P next to a value. Snake P next. And why does it even in this case where we have no we haven't there's an error with the print snake method. Wait, that is the error. We need to upgrade to increment the counter as well. I forgot that. So let's have a look. Element number 0, snake self, P next. Element number 1 has the same coordinates. Why? The addresses look okay, but why do they all have the same coordinates? I don't get that. Snake P next. Is equal to the address of snake tail. Does that mean that when dereferencing P next, no, we should get those coordinates right here. Let's print the snake right after initializing it. And then let me just put some stupid assert null equals 1 just to make sure it fails here, because I just want to see the very first execution. Ah, here the coordinates are okay. That's interesting. Then where does the snake get corrupted? Probably here. Yeah, probably here. So we get the first element from the snake. We store the x and y values in a intermediate value. Then we do we even enter this if case right here? Printf enter. Yes, we enter that. So previous x, previous y are saved here. Current x, current y are updated. Let's print the snake here and cancel the code, the execution after that. Okay, this contains the error. Let's see what happens if we execute that same code up here. Does not contain the error. So what's the issue? Ah, the previous x and previous y are never updated. Why is it not working? This is horrible. Previous x, previous y. No, this is also not update. Oh, what am I doing? So the point is we are updating the current values, but we have to, before we update them, we have to store them also in the somewhere. Maybe in temporary values or something like that. Int temp x is equal to p current x. Temp y is equal to current y. And then current is being updated. And then previous is being updated. This somehow doesn't work. Why? P current. Okay. So at least we now have a snake. But at the beginning of the code execution, it looks weird. So it looks like the snake is collapsing on itself. Why is that happening? Move the snake in the direction if the snake is size. Okay, I know why. Because the head element is not being updated and all the other elements are then successively updated to the head element. Yeah, but a non-moving snake is not an option anyways. Still, I would like to not collapse the snake on itself. Move snake. Maybe we have to assert that p direction x is dx is not 0 or p direction dy is not 0. Right, because when we now execute the software, then this assertion will fail because, well, we can't call move snake without a direction. That is an invalid input, so I will leave that assertion in here. Okay. Then we have to initialize the direction somehow. So if there is no event if no button is being pressed at the beginning of the game. Then wait is true while wait we do now. While we are waiting, while wait is true and STL poll events, and then we say if a key down has occurred, then wait is false. Maybe we have to say or STL poll event. Okay, this doesn't work. Grab kill -9 snake 7392. Oops, 92. So we wait false. No, this is probably not so good. Let's say if wait is equal to, or if wait, then we will do SDL delay, don't know, 500 milliseconds. And I'm not sure about this. Oops. So we are retrieving key down events. If there is a key down event, we set wait to 0. Didn't I just set this? Maybe I just accidentally deleted it. But somehow this still doesn't work. I don't get it. This is really frustrating today, I have to say. I've spent an entire day on this. The entire freaking day. While game. Then we poll events. If the key is pressed, wait is 0. If wait is 1, we wait. No, this is somehow this is odd. Maybe in the move snake method, maybe let's make this more generic. If we pass a direction that is null, we don't assert in file, we just say if that is the case, then we don't do anything and just return. Because, well, the snake doesn't move. Yeah, and that's our snake. And now we press a button and it doesn't work. Okay, but still, we at least we paint the snake correctly. So we move the snake, then why is it not moving? That's something I really want to know. We are setting the direction dx component to 1 if we move. which is okay, I would say. Then we move the snake. No, if it's equal to 0 and this is equal to 0. P direction is the pointer to the direction. That should be okay. Let's just print the direction. Direction dx is equal to some integer value, and dy is also equal to some integer value. P direction dx and p direction dy. Yeah, that's fine. That's working. If p direction dx and dy is equal to 0, then return. Print f return. Yeah, I know it's wrong, but let's just never mind about it. We somehow always return. Why do we always enter the return case even though p direction and wait, I don't get it. We have dx, direction dx is -1. But we only enter the return if p direction dx is equal to 0 and like dy is equal to 0. How do we enter this return then? Oh my god. There should be a compiler warning for that, in my opinion. This is an empty if statement here because of the semicolon at the end of the if statement. Can I? Oh no, I have no internet right now. I would like to enable compiler warnings for these kinds of things. Yeah, of course. Now it's working. Great. Okay, this looks already much better. That's good. Okay, guys. In the next episode, we will have to implement the snake getting longer every time it eats an apple. And we have to detect collisions with itself, because then the game is lost. And then that should be it. As you can see, we now have a moving snake, which is a good thing. And yeah, as you've seen great, there's a segmentation fault. No, an assertion. Okay, yeah, we also need to implement collision detection with the borders of the screen. And we have done and tried so much different stuff today. This was really hardcore, especially because this is really one of my first projects where I really use pointers. And why is that? That's because we used a linked list, or our own representation of a linked list in C, to represent that moving snake right here. So if you are interested in finding out more, then stay subscribed and let's stick around for the next episode. In the next episode, we will make the snake longer and implement collision detection. And then that should be it. Probably that's going to last another 6 hours or so.